Wasn't that bad.
All right, let's talk about digital signatures. Again, this is a very short recording. Okay, we can talk about the purpose, some security concepts, some drawbacks, and how it all works.
So every question is encrypted.
I actually encrypt the questions. You got to decrypt the question before you can even answer the question.
And your times are going to
All right, let's continue on. We've got to get done here. All right. The purpose of a digital signature is to signify intent. Has anyone ever signed anything electronically?
Yes.
Yeah, I mean, we all do it nowadays. To signify our intent to proceed. Okay.
What's neat about it is when your phone number comes up automatically with me even giving it to them. I'm like,
Yeah, there's a lot of stuff. They go through public records. They do all kinds of stuff. Okay. It gives us authentication and approval, also security, and also ceremony. Can you think of a ceremony having to do with a signature? What happened Pearl Harbor days? What happened at the end of the war? Remember the Japanese guy, and they got up on this boat, and they signed, and what does the president do all the time? Every signs an executive order, does it with a different pen, and don't they present that pen to somebody? And what about when you buy a house? Who's bought a house in here? Isn't that a lot of signatures?
Yeah.
That's like a ceremony. Crappy one, but it's a ceremony. Okay. All right. Okay. You should already know confidentiality, integrity, availability. We already know that. But we also have identification, authentication, and non-repudiation. We haven't really mentioned non-repudiation. Non-repudiation, I saw Wanda's ticket today, finally. She did sign it. So I knew she did sign this stupid ticket. She could not say she didn't sign it.
I swear I did not click on the email.
Yes, yeah. Okay. Okay, drawbacks. They could be lifted. I watched this movie again just the other day. Anyone ever seen that movie? You haven't seen that movie? Excellent movie. You need to watch it. Catch Me If You Can. I think I have like 5 copies of the DVD, actually. I don't know why. I was converted everything to digital. I'm like, what the heck? I have so many of the same movie. I must have really liked it.
eBay.
Yeah. All right. So drawbacks. We have lifting. We have forgery. We have document alteration. Okay. With email is actually in plain text. Did you know in your email client you can actually edit the message? You can. You can literally in Outlook open up your email, click edit message, change it to whatever you want. Years ago, I was messing with some people here on campus. So I took an email, changed the entire content, said it came from the president and everything, sent it out to everybody. And Arlene was like, oh my God, because it was something. It said do something. I said, I ain't doing that crap, and I deleted it. And they're like, that came from Dr. Braden. You need to do that. I'm like, heck no, I ain't doing that. And that was kind of the way I got the point across that you can edit emails and make them look real. Okay. You can't trust it. Yeah, we will rely on it for business purposes every day. It's kind of scary. Okay. Okay, do you all know what asymmetric and symmetric is?
Hey, well, that's only on your side, though, right?
What?
I mean, if you have the message, it's not like the person who sent it can see your address.
They can't see what I changed. You're correct. And if they did, the problem is it's stored on an exchange server. If I edit it, the exchange server is not going to say, oh, do we change the message? Here's the original. You're not going to see it. You'd have to go back to the source to see what they actually sent. That's why we use digital signatures to solve this problem.
So if somebody else logged into your account and say what you wanted it to say.
Exactly. Yep, it saves it totally. Okay, so we know what asymmetric and symmetric is. I will say there's a couple of you in this room who do not know. And you need to know it again. Symmetric. We all got this?
Yeah.
N times n minus 1 divided by 2. Trust me, there's a couple of you. I don't know who they are. It's probably you, Juan. Someone doesn't know. Okay, an asymmetric, 2n. That's how many keys we need. This will be on your test. Well, digital signatures, what they do is they prove something's been edited or not. So we have digital signatures. There's hashing problems. There's key problems. There's certificates. There's PKI. There's confidentiality. Digital signatures help us with things. See, the thing with a digital signature, if I take this email right here and edit this email, say this email came from someone who had signed it digitally, it would then come up and say this email has been edited because it actually used a hash function to determine if the email has been edited. But how many of you get, I know Tinker puts signatures on a lot of emails, but most places don't. So if you were, if Madison was to send me an email,
Can't they just edit the signature?
what? You can't edit the signature. You can't, because it's an encryption. You can't just edit it, because the signature is a mathematical formula.
Yeah, I get it. What I'm saying is they send the hash. They just, oh, this is the new hash.
The problem is you'd have to get it to it. The hash is based upon the actual message. You would have to edit the message and then recreate the hash. You can't do that after the fact. You can't. It should always match. So, all right. So that's what the hashing problem is. That we take this message. We're not doing this to encrypt the message. We don't want to make it secret. We just want to know if the message has been changed or not. That's all it's about. It's kind of like when I log into my bank. It verifies through a digital signature. Actually, that's actually through a certificate. But we use it to prove that the data has not been corrupted in any way. PKI, public key encryption, is part of that. But actually, that would be a good thing for me to add in one of these Monday night lectures since I didn't this time. Add PKI. Public key encryption is certificate authorities. It's the whole entire process of managing certificates, managing the request, managing the approval, managing the installation of them. When I worked on Tinker, I worked on a top secret network there for a while. We had the shielded cable and everything else, and that's a totally different animal to work with when you're having to use PKI for everything. Okay, so here's how digital signatures actually work. We hash the message. So as we take the message, we create a fingerprint of it, or a hash value that's specific to that individual message. No two messages should produce the same hash. Then we encrypt the hash with a private key. Okay. Then we send the unencrypted message along with the signature. The signature is the one that's encrypted with the key, so we know where it came from. And as long as we can decrypt it with the public key, then we'll know if it got edited.
What I'm saying is you've got email A, hash B, email C, hash D.
No, email A has hash A linked to email A.
Yeah, what I'm saying is hash B is the hash of email A.
No,
So
hash
can't
A.
you- What I'm saying is can't you just replace?
No, you can't. It doesn't work that way. It doesn't. What will happen is it'll pop up and say it's been edited. The problem is this part right here. See the second line? You create the hash, then you encrypt the hash with the private key. So what's the answer to the private key? The public key. The public key tells me who wrote it. Okay. Only I have the private key. You don't have my private key. So even if you recreated the cache, you could not encrypt it with my private key because you don't have it. Okay? All right. So then we send the unencrypted message along with the digital signature, which is encrypted along with the hash in it. You decrypt it and see if it matches. It's actually instantaneous. And it works out great. Okay. All right, it says recipient can read the message. Message can be verified as unchanged. Now, what if I don't verify and someone edited it? Now, once I was running a website for a guy and his certificate expired. So I had the choice of running his website for 24 hours without a certificate.
Oh, yeah.
I told you about it. What do?
Make sure you ran it
I
without.
ran it without it because he didn't want to lose the business. So for that 24 hours, it was not encrypted. The sign up for Gen Cyber last year and the 5 summer camps this year was unencrypted. I didn't realize it until this year on camp number 4. When someone says, "Why isn't this encrypted?" I'm like, seriously? Because I don't see it. I don't see what it's like to sign up. I didn't realize it was unencrypted. Until someone pointed it out. Then what I did is I went into the form software we use. And since the form was really made 2 years ago, now they require you to have encryption. But 2 years ago, it was an option. And since it was made 2 years ago, there was the question that I didn't even realize there was a question. So I literally had to do just check a box that said encrypted was fixed. But how many people signed up with their personal information, including social security numbers?
Everyone's got your social number.
Without, yeah, they're already out there anyway. But it was like, wow, I can't believe it. And it was a teacher who pointed out, though, why isn't this encrypted? I'm like, what do you mean it's not encrypted? Seriously? I'm like, you're right, it's not encrypted. That's pretty stupid. But, I'm not the one who made the form. But, okay. So, with this, sender can be verified as correct because of the public-private key. How it works is we rehash the message, use the public key to decrypt it, and then compare them. So even if Madison did rehash it, it wouldn't match the public key. Okay? Some problems is if two messages have the same hash, they then could potentially have the same signature. Okay? So effectively the signer has signed everything with the same hash. Use a good hashing algorithm. MD5, and here's an example. Here's hello, right? Here, okay? And you'll see I did it again, and you'll see erase, but look at this hash value. You see how the hash is identical? I know it's hard to see, but they're identical. That's one of the problems with MD5. It's called collisions. MD5 does have known collisions, where in this case, I hash the word hello, or I hash the file hello, then I hash the file erase. They're two different programs that they produce the same hash. MD5 is still used, but under very certain circumstances, it can be bypassed, is what this is showing. Okay. And if you want to know more about it, search MD5 collisions. I'll tell you all about it. Okay. Key problems. How do we know the public key we're using to validate the message belongs to the sender? So we got Juan over there who's been compromised. So somebody hashed the message pretending to be Juan. I can't tell. I don't know that because the public key I got matches the private key that the bad guy made. So someone broke into Juan's account. I don't know. I can't verify that. I cannot tell if the sender's been compromised. All I know is it came from someone using the sender's account. It's the same way. If you got a husband and wife, let them do something on your behalf. Is it technically them doing it? No, it's you doing it on their behalf, but it's one of those things. It'd be hard. So. All right, solution, we could have digital IDs. IP version 6, y'all know what that is. I'm pretty sure sooner or later we'll all have one. You can actually go, I think it's Horizon Electric. Horizon Electric, yeah, that's right. Go to Horizon Electric, you can actually get your own private IPv6 tunnel and key. So you can have your own private signature and start putting on everything. So, but yeah, you can do digital IDs, you can have everything with it, you can have serial numbers, and it's. But again, we got the problem here. I mean, what happens if something here is like signature number or certificate number? What happens if the PKI system is interrupted or someone, like for a while there, someone was issuing fake certificates from Microsoft. So at that point, that would throw that in. So I don't think there's ever going to be a total fix for everything, but they're doing their best. All right, PKI. I need to cover this more in depth. It's hardware, software, policies, procedures, everything. It's for corporate, DoD, education. It's used for everybody. It's a public key and cryptography or public key encryption system for managing certificates so you know who's who. You know how when you go to your bank, so I go to my bank and I have to log in. Okay? So I know it's them because of the certificate installed on their system. They know it's me because of my login. But what if my bank can't do a certificate? Couldn't I then access my bank without logging in? I could. And that's what happens in like Tinker. If you have two secure systems, they each issue certificates. Now where they talk back and forth with a certificate installed. But can you imagine my bank having to issue me and get me to install a certificate? For most users, they'd never be able to figure it out. Because first of all, I'd have to do a certificate request and get one issued and get it installed, and it's a very time-consuming process to be able to do. So that's why they don't. That's why we just use usernames and passwords. So certificates would be better, but I don't think we'll ever get there. I don't think so. All right. Here's just a picture of it. And we got a certificate request. Certificates are stored in the repository, and you have the authority giving them out. They also have something down at the bottom called the certificate CRL, certificate revocation list. When I ran my company, I would issue certificates. My personal certificate was free because I sold certificates, so I got a free one. It's good for 10 years. What are the odds I'm still using that certificate today? Who keeps something for 10 years? No one. Yet that certificate is technically valid for the next 10 years. Well, I guess it's only about 5 years now. But they have the CRL, certificate revocation list, which keeps track of certificates that have been revoked so they know when to remove them from the system. If you look in your computer system, under internet connections in your browser, there'll actually be a CRL in there. And actually, maybe I can, let me see, I might be able to find it. No guarantees. We want internet options. Should be under privacy security. Okay, which one? It's in one of these two. Maybe it's in privacy. Advanced sites, import advanced, clear sites. No, it's in one of these areas.
Just in
Darn, it's in one of these.
connections?
I thought it was right up here. There's an option to
Is
see.
it restricted? No, it wouldn't be restricted.
Huh? But there's an option where you can see the actual certificates. Browsing history, advanced, it's not there. Manage add-ons, land settings. Oh, here we are, certificates, there they are. Okay. We can actually see, these are what's called the intermediate certificate authorities. When I sold certificates, I sold them from Komodo. Okay, here's why I did Komodo. If you look at root certificates, we'll have VeriSign should be in here. Okay, here's VeriSign. Okay, VeriSign sells certificates for, back then it was $349 a year. Kind of expensive, do you agree? Okay. I could buy certificates from Komodo for $45. Some for $349 a year. See some profit margin here? Which one's better? They're identical. They're exact identical systems. But these are what's called intermediate authorities. So I had to install two certificates. I had to install Komodo's and then SecureTrust at the time, but they've changed a little bit now, it looks like. So basically, when you wanted to check if my certificate was valid, instead of going straight to VeriSign, you had to go to Komodo, which then went to VeriSign for you. But I mean, but it saves so much money. No, I did sell for $349, I sold for $149. I still made $100. But the point is, it can be done. Okay, and I wanted you to see. We should be able to see our CRL in here somewhere. Where is our CRL? Don't know where they put it. But there should be one in here. Certificate request. I don't know where it is. And if you ever want to, like, say we clicked on VeriSign. Okay. Where'd VeriSign go? There it is. If we click on VeriSign, you can actually open up their certificate and view this, the algorithms they're using, SHA 256, and you can see it's valid until from April 2008 until December 2037. Wow, that's one long certificate. And you can even see the path. Obviously, they are a root authority. So now let me go open up Komodo again. Komodo was, where'd Komodo go? There it is, this one here. If I look at this certificate path, you'll see Komodo actually it's changed. It used to go through SecureTrust, but they don't anymore. I don't know where the CRLs are. They are in here somewhere. But this is how your computer manages it. And those are updated all the time by Microsoft. So whenever you go to your bank gets authorized through one of those. Okay. All right, confidentiality says the nested save problem. It says encrypt a message, not just a message digest. Then encrypt the results using your own private key. The results of both the sender and receiver are assured no one else can read it. But most of the time, we don't really care about confidentiality. Is my mortgage documents that I've seen, are those secret? No, they're all posted online. You can go to whatever that place, I can't think of the guy's name, and you can actually see every time my house was sold or who bought it and taxes I paid and everything. We just want to know that they're legitimate and not fraud, but they're not encrypted. Okay. Okay, now ethics. Phishing and social engineering. People all the time try to steal stuff and sign for other people, and it's crazy. And if you guys ever get any really good spam phishing emails, I'd like to do. I use them in presentations all the time, so send them to me. Okay. Handwritten signatures are unreliable. Okay, we're all, at least in the age group, where I'm assuming we all know sign our name, correct?
But everyone behind us does not.
They do not. My stepkids do not know how. They were never taught the complete alphabet. I asked, what do you mean? And they're like, yeah, we didn't have time, we didn't get to it.
They took it away.
That's crazy.
We're not teaching it.
They don't teach them.
They didn't teach cursive. I mean,
That's crazy. Why would you not teach?
Yeah.
So basically, their signature is block letters. How hard is it to? It's so much easier to fake block letters than it is a signature. But that's what they did. So this is digital signatures provide solutions but create new problems. New problems can be solved, but whenever you create something, you're always going to have more problems. Okay?
And at 5th grade, I was like, at 5th grade, we stopped learning cursive. We straight stopped learning. We
That's
didn't,
crazy.
it didn't matter.
It's like math tables. Bethany was in 5th grade, and she, was whatever, somewhere close to 5th grade, and she brought home a homework assignment of basic math assignment. And she said, I can use the calculator. I said, no, you can't. It's basic math. And she goes, no, I can use the calculator. I said, no, you can't. So the next day she brings me home a note from the teacher. Bethany's allowed to use a calculator on here. So I called her. I said, why? Because we need to teach them how to learn a calculator. No, you do not need to teach them how to use a calculator. They can figure that out on their own. You can teach them
but
basic
that's
math.
the issue that you have nowadays. I mean, we've been to incredible stuff. They don't even know how to give you change.
Oh, they don't. Unless it,
We were joking around with one of the ladies there. Said, "Oh, you're supposed to give me 420s," and she was literally trying to give me 420s
like,
when we
no.
only gave her a 20. Which
I joked around with the grocery store one day. I said, oh, those turkeys they're free today. Jokingly said that. I get home, they didn't charge me for a big ass 25-pound turkey.
Oh,
I was like, seriously? The turkey was not on there? I'm like, oh crap.
yeah, they got
No, I
caught.
didn't go back.
They got caught.
Okay, but now it affects the signature. What about a date? That's a whole nother story. See, we keep creating solutions, but solutions give us more problems. Okay? There's a lot of stuff on here you can read about. Okay? All right, digital signatures wise, there's not much on this list. There's actually very little. So just get a general idea of it.